This is chapter 9 in your text. I want to demonstrate a schedule calculation for you here, and I do this a little bit differently than the book does. I try to keep this simple and then add to it afterwards, and I'll get into more about adding to it later. But take a look down below here where we have a simple node where you have in the lower left-hand corner an early start, which is the ES in red. Upper right-hand or left-hand corner, I've got the duration, which is D. The upper right-hand corner is the float, and the lower right-hand corner is the late finish. These are the ones that we're going to work with right now. The letter up here in the schedule calculation just relates to an activity. So R could be excavate the site. This could be layout, foundation, inspection, whatever. But those letters represent an actual task. So I just want to run through this with you first and read your chapter because there's a lot of good terminology and there's a lot of really good information in there about schedules. So our very first activity, I have to start with 1. And this is a little bit different than your text again. So just bear with me. But I always start with 1, and I'll explain that in a minute. But since our activity R's duration is 4, it could be 4 hours, 4 days, 4 minutes, whatever it is. To get the next early start, I have to add this 1 to my duration. So 1 and 4 is 5, and that gives me my next early start. So this is going to be 5 here. This is going to be 5. And this is going to be 5. So what this is saying is that I have relationship lines here. And you can see that these lines start here at R, activity R, and then they extend out to the next activities, which are A, G, and C. So that means that A, G, and C cannot begin. These activities cannot start until R is complete. So if R lasts 4 days, I can't start A, G, or C until day 5. And that's why I add the R, or the 1 in here in the very first activity. So as we move forward, let's just go forward. So 5 and 4 is going to be 9. And I'm just going to type that out here just so we know. And then let's see here. 3 and 5 is 8. And then 5 and 6 is 11. So bear with me here. I'm just going to copy this. Copy, paste, and then I'm going to paste this down here. I'm trying to do this with Bluebeam so that you guys can kind of, it's better than me scribbling on this stuff. So 5 and 3 is 8, so I'm going to put an 8 right here just for the time being. 8. Oh boy. 8. And then 6 and 5 is 11. Probably should have set this up before I started, but that's okay. So what happens here is that since W can't begin until A, J, and M are complete. So I'm going to hold off on this 9 right here. But I do have G, both G and C converge on J. And so on the forward pass, which is what we're doing here, we're working from right to left. This is the forward pass. So on the forward pass where I have 2 activities that converge on 1 like this, I always have to use the bigger number. So J is going to begin, it cannot begin until day 11. So do you guys see that? So look, J can't begin until G and C are complete. And so since since my start date and my duration is 11, J can't start until the 11th day. Doesn't matter. This is 8. That doesn't matter. So I know that M, the predecessor of M is going to be C, so this has got to be 11 days as well. Hang on just a second. And let me see if I can get in here and change that to 11. Probably be easier if I did this by hand. So okay, so let's do the next ones. I want to copy that. I'm going to paste it here. Paste. So what do we have here? 11 and 3 is 14. And 11 and 5 is what? 11 and 5 is 16. So again, now on the forward pass, we have to use the bigger number. So 16 is bigger than 14. And then in this case up here, I've got a 9, I've got 16 and 14 that lead into W. So I cannot begin W until the 16th day. So I've got to put a 16 in here, and you guys can kind of see how this works. I mean, again, M can complete after 14 days. J completes after 16 days, and A completes after 9 days. Since W cannot begin until all 3 of those are completed, I've got to use the bigger number on that forward pass. So now, since W is 2 days on duration and it can't begin until 16, I know that this last day here is going to be 18. So 2 and 16 is 18. And enter. Spread that out a little bit like that. And so I've got my project here is going to last. The duration on this particular project is 18 days. I'm just having a tough time here with these boxes. And there's another one. Okay, so hopefully everybody can kind of see how that works. That was the forward pass. So now let's do the back pass. So if I take my late finish and I subtract my duration, I will then get my next late finish. So 18 minus 2 is 16. And these are all going to be 16. This one, 16. And then we work our way back. So in this case, J and M both converge on C. So I've got 16 minus 3 is 13. I'm just going to copy this number. Copy. Paste. And then paste. Move it down. We'll move this one out of the way as well. So this one should be 13. 13. And then 16 minus 5 is 11, right? Correct me if I'm wrong here. So 11. So on the back pass, whenever I've got 2 nodes that converge on 1, I'm using the smaller number. So in this case, I'm going to have an 11 here. And the one up above this, it's the same thing. This has got to be 11 as well. 11 here. Okay. So let's see here. I'm just going to copy these. Copy. And this, I'm just putting these numbers out here as a reminder to me what these numbers are as we go back. So in this case, I've got 11 minus 6, which is going to be what? 5. So put a 5 in there. 11 minus 3 is 8. 16 minus 4 is 12. Correct? Yes. So again, on these, I'm going to pick the smallest number, and that's where we're going to end up right here. So this is going to be 5, and it really has to be 5. So I've got my forward pass and my back pass complete. Now we can go in and fill in the green numbers, which is the float. And basically the float, you figure out the float by adding the early start and the duration, and you subtract that number from the late finish. So in this case, I've got 0 here. So 5 minus 5 is 0. 16 minus 9 is going to be 7. So that activity A floats 7 days. 11 minus 8 is 3. And then 11 minus 11 is 0. And then what is this? 16 minus 16 is 0. So our float there is 0. And 16 minus 14 is 2. And 18 minus 18 is 0. So that's how we do it. And this is correct. So I think what I want to do here is draw out. Let's go ahead and draw the critical path. So my critical path, I started the wrong way there. So my critical path starts with the first one, R, and it's basically going to follow the 0 critical path. So I'm just going to draw this out. So I've got to go from here up to J, and then basically we go from J to W. And so that is your critical path. Your critical path, if you look at your text at all this stuff, your critical path is a string of activities that has 0 float. So the critical path actually determines the duration of the project. And that means that the rest of these, A, G, and M, the rest of those basically can float. Okay? So these guys here, I've got a floater here, I've got a floater here, and I've got a floater here. So look, A can actually start 7 days after the 5th. It could start on day 12 and still complete without pushing the project back. G could start on day what? Could start on day 8, and it would still finish by day 11, and we would not impact the schedule. And same with M. So when they talk about float, they're talking about activities that can move a little bit. They could maybe start a little bit later than they need to, and it's not going to impact the total duration of the project. So this is how I do it. Your book explains it a little bit differently, but go ahead and